Okay, welcome everyone to this second seminar, which is a part of 3 seminars we're doing in the run-up to the Barclays DerivHack 2019. The next session will be on the 9th of October, next week at 2:30 London time. And if you missed the previous session, we have a recording on our blog. That's blog.daml.com. I think it should be the first link there. All or at least most of the material that you're going to see today can be seen in a GitHub repo, for which the link is there on the slide, and also I've pasted it for you guys on the chat. And we suggest that you either star or watch the repo, because we'll be updating that over the next week or two whenever there's changes to the CDM, or if there's new material we need to add on there. So that's one way to keep in touch with us, and the other way is through the Slack channel DerivHack2019 on damldriven.slack.com. And so let's go over the agenda for today. We're going to pick up from where we were last week. We spoke about Daml models, and we're going to talk mainly about the CDM in this session. But we're going to stop short of going into the cloud deployment on Daml, which will be the topic for next week. We're going to split the 90 minutes into 3 sessions. The first one will be working with the CDM in Daml. The second one will be CDM message ingress, egress, and automation. And the last one will be creating reporting UIs. And we've slightly modified the format from last week so that at the end of each of those small sessions, we're going to try and field some of the questions on the Zoom chat. And just to emphasize that, that's the Zoom chat, not the Slack channel. So please post your questions there in the Q&A. So without further ado, we will go on to our first presenter.
So as said, this first section will be about how to work with the CDM and Daml. So the first thing that you typically will start with is to get all the CDM types in Daml that you can, for example, get from the Rosetta portal, or we also check that into the repo link that was just shared at the beginning, where we have all the material that we showed now is all in our DerivHack2019 repo. And there you will also have the Daml types included that will be used as part of the hackathon. But just in case to show you, you can also go to the Rosetta portal and then click on this download button here, and that will give you a zip file. And the zip file includes a Daml folder, and there you have like subfolders. Org is the CDM, and that includes all the data types here. So all this class, the CDM classes, so you see here account, actual price. So everything that you have also specified in the Rosetta syntax, but compiled here into the Daml format. You also have the enums in here. Here you have the function specs that were recently introduced in the CDM, and also some meta classes, data types, and meta fields, and a zone datetime field for zone datetimes. Now this alone doesn't help very much because that's all data types. And as we have seen in the last session, what we actually can create on the ledger is contracts. And in order to create contracts, you need to have a template definition. And that's also where we dive into now. So we created here a small Hello CDM example. So it's very simple. Like you will see, it's not really doing a lot of sensible things, but I think it will show you the most important features of how to work with the CDM and Daml, and I'm sure you can translate that to a more sophisticated example. So let's look at our simple example here. So in here, what I created a transfer template now, and it holds now such a CDM event. So that's now basically the payload of a CDM event message. But we also need to add certain party information now, because as you have seen last time, you always need to have certain parties signing a contract. So in this case, what we do, we add an owner and we add an observer. The owner signing the transfer contract, and the observer can see it. So that's an important takeaway here, because given that the CDM itself doesn't have a first order concept of a party, and we need to add that next to the actual message. So what we download from the CDM portal, like, is all the data types, but we also need to include some party information. And that's what we did here in the template. So the template, we combine the actual payload, so in this case, a CDM event, with some party information. And then those parties can either sign a contract or they can see it. So maybe let's already look at a more precise example here now. So I also recall from last time that we have this scenario runner, where within this IDE, we can on the fly code up some tests. And like what I do here, I wrote a small build transfer function, which takes a decimal as input, and it builds up a fully populated CDM event. Now, as you see here, that's quite a few of lines that you have to write here. And the main reason is that Daml is a strongly typed language. So for all the fields where you, for example, want to set an empty array, you actually need to specifically set that. And also for all the optional fields where you don't want to set any fields, you also need to explicitly say that this field is none. That's just like the complexity that you get a bit if you work with the CDM. But yeah, apart from that, it should be pretty straightforward. I mean, like the CDM event, that's just like all the fields that you have. So like we say, like, okay, we don't add any account information. The action field is set to new, and then we just like start building up the event. Down here, you see like we add the primitive event, and we add some transfer information. Everything for this specific example is now hard coded, except for the amount which goes into the function. And down here on the cash transfer component, we actually see that we set the amount here. Like in the second session, as already mentioned, we will show like how egress and ingress works. So there actually, like, we will show how from starting from a JSON file, how can we get more examples in, because like sometimes like you might not always want to code up those examples here by yourself. So you can also like load them from JSON files, but that's part of the second session. And the only other thing like that I want to mention here is that I added a small function called set global key. So for those of you familiar with the CDM, so CDM events have a global key, which in old times was called Rosetta key. And like there I wrote a small function in this main file here, and that does nothing else than taking a CDM event as input, returning a CDM event. And what I do first here is say like, okay, I set all the meta information to none. I then take this event, and then I call a hash function on top of it. That's this SHA256 function that we call. That simply then generates a hash from this event, and then we bind this global key to the meta field. So that's how you can set global keys within Daml if required. Yeah, so now we have a nice function taking an amount as input, building a transfer event. But as I mentioned initially, that alone you can't put on the ledger. So let's look at a scenario now. So what we first do is like we get two parties, we get Alice and Bob. Now we build such a CDM transfer event, pass in the amount of 100. And then we actually create our transfer contract now. So that's really something that we can put on the ledger now. So that thing here, so like an instance of this transfer we can put on the ledger, and that's exactly what we do here. So we say that Alice submits a create command where she wants to, where she creates this transfer, where we bind the transfer, like the CDM transfer, to the event. And then the OLA becomes Alice and the observer becomes Bob. So now let's look at the result here. Let's look at the table view. So we see Alice sees that, Bob sees it. We have an ID assigned to it. We see the status is still active. And then given again the highly nested way of how CDMs work here, like you have a lot of nesting levels again. So yeah, sometimes that can be helpful, sometimes not so much. So I personally often look then here in this highly nested structures, I look at the transaction view, because then at least you have like a more readable JSON syntax here, where you see like the real payload. And there we see here now, and the CDM event payload together with the owner, who's Bob, and the observer, sorry, the owner who's Alice, and the observer who's Bob. And we also see that it's known to Alice and Bob, Alice because she signed it, and Bob because he is an observer on it. So that's basically how you can create new CDM messages within Daml, and then also put them on the ledger in this scenario runner here. Now let's look at the simple choice that we had. So we added something like, I mean, the example is called hello CDM. So let's call our, say, hello choice to it, which can be called by the owner. And what does that choice do if the owner calls it? It's again returning such a transfer contract. It takes in whom to greet text as input, and then it creates the same transfer basically. So that's what we say here. It creates the same, but it updates the event. So that's what we can, that's what this create this with event means. So owner and observer stays the same, but we update the event. And how do we update the event? We call an update identifier function on this event that we have on the contract, and to whom to greet goes in. And there we like the update identifier function. That's a function which puts the identifier value to hello, like to whom to greet, and it increments the version number by 1. But we will go through this function now step by step. So as said, the function signature is like like a text goes in, a CDM event goes in, and a CDM event goes out. So now the first line is here. We say like, okay, on this CDM event, we want to update the event identifier. If you actually look here at the event identifier, that's actually a list of identifiers. So what we do now is we loop over all the identifiers that we have in this list of event identifiers and update the assigned identifier value, because at the end of the day, we want to update something in here. So we want to update the value and we want to increase the version. So we loop over all those identifiers. Now in Daml, how it's written, like there's not a for loop, but you map actually over all the elements. So that's what this map function does. So the map function applies a function to all elements in a list. And in this case, we set the identifier now. So let's look at the set identifier function. The first line, we simply say like, okay, if we look at this example, an identifier has assigned identifiers. Now let's make our life a bit simpler. I mean, the assigned identifier is actually, again, an array type, but we simply say like, okay, we never deal with cases where there is more than one assigned identifier. So we simply get the first element out. So we call the head function, which gets the first assigned identifier. If there would be none, this code would fail. If there would be more than one, we simply wouldn't update the others. But like we make our life here more simple and simply say like, we assume that there will be never more than one. We can obviously also make that more generic. Then we got this assigned identifier out. Now in this later part, we again call now a function called set assigned identifier. And then what we did that, we wrap it again in an array, and then we can set the assigned identifier on this identifier, which goes into the function. So let's look at the set assigned identifier function. Here again, we make our life a bit easier. If we look here at the version, we see that the version is sum of 1. So the version is actually an optional type. So in theory, you don't have to set an option. But again, we assume, we don't have to set a version, but we simply assume that there will always be a version present. So for this reason, we simply call the from sum function, which simply gets the value if it's sum, and it would throw an error if it's none. But given that we made the assumption that it will always be there, we can call that. Then we simply like bump the version by 1. And then given that it's an optional type, you have to again wrap it into sum. Now for the identifier, we do something, or like we simply say now, set the value now. So we say like, for the identifier, set the value to like the string concatenation. So if we look at our example here, an identifier is actually of type field with meter, which has a value under meter field, but we simply update the value here. So the meter just stays as it was before. In our case, it's none, like for this specific example. So we just keep it as is. And then here we simply return the new assigned identifier with the new version and the identifier. So why did I show you that? Given this highly nested structure in the CDM, you often have to update fields in a bit more lower nesting level. And for this, you often have to work with lists. You have to work with optionals in the CDM, given that so many fields are of type optional and they're also of type list. So there I showed you now a few functions like the map function, which applies to a function to all elements in the list. The head function, which returns the first element, the from sum function, which simply returns the value of the type of sum. What I recommend, maybe if you start working in more anger here, to go to our docs, to docs.daml.com, go to writing Daml, go to the standard library, and there we have two modules that you can import, and that's what I already did here at the front. So at the top, I imported da.list and I imported da.optional, and that exposes an entire set of functions that you can lose. So for example, at da.optional, you see here this from sum function that I already showed you. So it's again here written, it extracts the element out of a sum or throws an error if its argument is none. There are some other useful functions like the cat optionals, where if you have an array of optionals, it would throw out all the none values and you would simply remain with an array of the real values, or list to optional, where starting with a list, if the list is empty, you would get an optional. If you have more than elements, the first element would be wrapped to a sum, or optional to list. So a lot of handy functions that you can use, and I recommend or at least if you come to the problem that you need to work with a certain optional type or list type, and there are a lot of handy functions on lists you can, for example, sort. So maybe skim a bit what's available on this end. But yeah, what we do now is we want to call our say hello world choice here. So we go down to our scenario and now say, okay, Alice exercises a choice now, taking this contract that we created before as input, calls the say hello choice, and it greets Bob. So let's look at our example here. In the table view, we see that a new contract got created. It has ID 1.1. Again, in this table view, given the highly nested structure, not so nice to look at, but let's look at the transaction view. And we still have the first one on it, but it got consumed already now. And we can now look at the second, where we see, okay, a say hello choice was exercised on the first the contract that we have, and a new transfer got created. And if we look here at the event identifier, on the assigned identifier, we see that the identifier value now is hello Bob. As you see, that's where we traverse through the tree in the Daml message, updated the value to hello Bob, and increased the version. So worked nicely, I'd say. That's closing the first part of the how to work with the CDM and Daml. So basically how to get new messages in, using our scenario runner, and how to execute a choice, a bit also how to work with lists and optionals. The second part that I want to talk with you about is it's not really a difficult feature, I would say, but it's slightly more advanced, but it's extremely powerful, and I think it's extremely valuable in the concept of the CDM. And that's the concept of contract keys. So what is a contract key? If we look at our scenario result here, we see that each contract here, and we can also show at archived ones, they get a contract ID assigned. But how that contract ID looks like, that's extremely platform specific. So depending on which platform you run it, you might get a different format here. So you can't directly use ID. What you can do is you can, for example, write a choice which takes a contract ID as input. So I could, for example, say okay, I make my say hello world here more complex and say it takes another contract ID here as input, another transfer here as input. So that would be a pointer now. pointing to another transfer. And that works as well. But with contract keys, I can also assign a key, a more readable key, to such a contract. And the key then, for example, could be related or can be related to the payload which is in here. So I could say, like, on any of the fields that I have here, I assign a key to this transfer. So why is that important? It has two main advantages. The first advantage is that it guarantees uniqueness. So among all the messages, or in this case, among all the transfers that I put in the ledger here, I can guarantee that there will never be two transfers on the ledger having the same key, with a small caveat that I talk with you about in a second. The second advantage next to uniqueness is that I can fetch then other contracts basically on the fly. So like in this do block, I could say that I want to fetch another transfer by only specifying the key of the other transfer. And I will show you that in a second now. But for those of you who are familiar with the CDM, that actually might ring a bell. So the CDM has this concept of global keys that we already saw. So that actually nicely maps to a contract key in Daml world. So basically, because if once you assigned a global key, for example, to a CDM event, you basically say that you never want to have two CDM events with the same global key on the ledger. So if I simply now assign to this transfer here a key with the global key of the event, I could guarantee that there are never two transfers on the ledger with the same payload, with the same CDM event payload on the ledger. The second relation with the CDM is the concept of lineage. So you might know that the CDM has the strong concept of a lineage, where within the lineage block, you can also quickly look at that, you can actually point to other payloads. So for example, you can say, like, I point to another cash flow reference, I point to another contract. So once I have like a message on the ledger having a lineage and I want to do something with it, I could fetch the contracts which are in this lineage block on the fly by simply saying, like, okay, I want to fetch now the contract having this specific reference. And now let's look at example to make it a bit more specific. So the first thing that I do is I add key, I add the key information to my transfer. So how does that look like? I only have to add those two lines. I need to write another function, get global key. So that's very simple now. So the get global key takes an event as input and it gets the global key out. Now here comes the small caveat that I mentioned. So given that there's typically no single party on the ledger who sees all the contracts, you need to say among which parties a key is unique. And that's exactly what we do here. So we need to say who's maintaining the key. So among which people, among which parties, the key is actually unique. And then you can assign the real key. In our case, that's the global key. We could also say that multiple people actually maintain the key, so it's unique among multiple people. So then I'm making an array and, for example, say, you know what, the owner and the observer for some reason are maintaining the key. I mean, we can also make it a bit, or we can also extend our model and say, like, you know what, I actually want to have like global uniqueness within my application. So I simply add a party who sees everything, and I, for example, name that operator. So like to each transfer that I add, I say, like, there's always an operator party, which also needs to sign my payload here. And then I say, like, okay, the operator is actually the key maintainer. So like the operator makes sure that there's like global uniqueness among all my transfers. And then you have a single party on it, making that true. But that's really up to the Daml model that you write. So there's really no right or wrong here. So in like our specific example, we say that transfers are owned by a certain party, and this party also maintains the keys. So like this transfer is unique within this owner party. So good so far. So like now that showed uniqueness. So let's look what that means now in our scenario. So I mentioned before, it wouldn't be possible to create the same transfer twice. So let's actually try that now. Alice tries to create the same transfer now again. And now we actually get an error in the scenario. So then the scenario directly checks whether this works out or not. And now we actually get the error that we expected because we have a unique key violation for that key. So we can't do that because you can't now, given that we exposed keys, and create the same contract twice. Let's look at the lineage aspect that I mentioned. So like I haven't really exposed lineage, but I'm sure you can translate that. So what I did here now, I created another template, which is called show payer party. So what does that do? And we have another template, which is signed by the SIG. So like if a signatory, it has two additional fields, the owner and the reference field. And that has a non-consuming choice called show party, which returns an optional CDM party. And here now comes the important part. So this line fetches our transfer now via the key. So you see here now, I've never really say like neither here on this, like on the payload, on the template, nor on the choice what goes in, I exposed like a contract ID field. I only had owner and reference on it. But given that this transfer here is exactly keyed by our party in iText, I now can say, fetch me this transfer via the key. What does that add transfer mean? That's basically you say like, I want to fetch a transfer. So now you could imagine that I have another template here called, I don't know, like transfer to, like, or foo, whatever, having the same key. So we somehow need to actually say what we want to fetch. And that's exactly doing this @ sign. So the fetch by key first says like, okay, what's the type of the contract that I want to fetch? And that what's the key of the contract that I want to fetch. And then I get back the contract ID and I get back the payload. But now you could imagine now if I have something like more complex in here where I say like I have a lineage field in here. And why is it not? Oh yeah, I need to actually write CDM.lineage. And like something like that. Now I could imagine that I actually go through like my lineage fields that I have here. So go to like lineage.cashflow reference, like take the first element and then fetch a cash flow similar like I fetched my transfer contract in here now. Once I wrap like a cash flow in a real contract. So I'm sure that you can like connect the dots here, or that would work. Like last but not least, I wanted to show you like how you get like a party, like a specific party, for example, out of an event. So here we said like, okay, we want to find the payer party from the event. So what do? We like get the first transfer. Again, we make our life a bit easier here. So we don't loop over all possible transfers, but we simply say like, okay, let's get the first transfer. Same with cash transfer, make again our life easy. Let's get the first cash transfer. And then on the cash transfer, we select payer receiver, payer party reference, external reference. Let's get the value out of it. Simply assume it's always there. And then we call another handy function, which is the find function. So from all possible CDM parties, we get the party which has an external key, which is the same than our external reference here. And that's what this party that's what this function does here. Either you find such a party or you don't find such a party. That's the reason why it's of type optional. So another small detour to how to work with lists. That's it from how to work with CDM and Daml. I hope that was helpful, and I would open to a small Q&A now, depending how many questions we have.
Yeah, I'll quickly comment on a previous question that we had, which was why do we name the fields on the transfer contract as owner and observer and not buyer and seller? It's simply here for demonstrational purposes. We use a very simple example. Of course, you would in your real model use more names with more semantic meaning, like buyer, seller, or payer, receiver. But here we really try to keep it simple. Also the say hello choice is really just a dumb choice, as we don't want to show too much here of what will actually be required at the hackathon.
We have another question still open. Can one party have more than one instance of a transfer? In that case, will it fetch all the contract IDs? So obviously, one party can have more than one transfer, but not with the same key in this case. So like as seen here in our test scenario, like Alice tried to create the same transfer twice. That didn't work. But Alice could create another transfer with another key. So like we could, and we can also quickly try that. We could say like create like, now we say like transfer to equal to like transfer, and then to say like, I need to update the metaphor here. So we could say like transfer to transfer with, and then so test. Now this should work. So now that worked, because now we created another transfer having another global key. So that's basically the uniqueness properties that you get when you use contract keys. But like obviously Alice then has two now two transfers actually like on the ledger. Let's remove the choice here, and then if we look here, like now we see Alice has two active transfers. Yeah, that's true. I mean, the other thing is the suggestion. Yeah, that's definitely a good one. So we are actively so the questions like it would be nice to have autocompletes, and I agree with this kind of highly nested structures. And we are always like adding more features to the ID. That's simply one that we haven't added yet. But I agree that this would be very helpful for such data types. Any other questions? In the fetch function, you should contract ID pulled by party key or contract key. So there is not really a difference between party key and contract key. So like a contract has a key. So there's not something like a party key, but a contract simply has a key, but a key always needs to have a party field so that you can actually say like who's maintaining the key, and then like a party can simply fetch a contract via the contract key, but there's nothing like a party key like as a concept in Daml. I hope that makes sense.
Okay, so I think we need to move on, but do keep on putting your questions on the QA tab, and we'll answer some more of them after another short session.